Hey Precalculus, I've got a new video for you. It's over section 2.3 from the textbook. I'm going to split this one into two different parts. The first one is going to be a series of videos in which it spans homework over Monday and Tuesday. So we might have 3, maybe 4 videos on just section 2.3 lesson 1. So let's get to it. First one I want to talk about is from page 116. It's number 7. So this chapter is all about functions and how their graphs work. This section in particular is just talking about lines. So the first thing I wanted to do was use a little geometry. What they're doing is they're giving us a parallelogram. They're giving us some kind of polygon. And they're asking us to prove it is using the line segment sides. So the first point of this polygon is negative 2, 1. That's point A. Then we have 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. 4, 0. And then negative 1, 2, 3, 4, down 2. So at first glance, it kind of looks like a parallelogram, okay? But what we want is actual proof. So it would be helpful if we knew sort of like what the definition of a parallelogram were. Back in the Math 2 days, maybe even Math 3, you guys should have talked about how a parallelogram is any quadrilateral that has 2 pairs of parallel sides, 2 pairs of opposite sides which are parallel. So if you remember that little symbol, it was the little triangle. We need to prove that these two are parallel and that these two lines are parallel to one another. Like that. Those are the symbols for parallel. When you plugged it, you got it. So, what do we know about parallel lines? Well, we should know that parallel lines have the same slopes. So all we got to do is show that the slope of AB equals the slope of DC. Then we have to show that the slope of AD is equal to the slope of BC. All right, so M is equal to the slope of this line segment is the rise over run, so up 2, right? 1, 2, 3, 4, 5, 6, 7, 8. Up 2 over 8, which is equal to 1/4. This one should be the same thing. Up 2, right? 1, 2, 3, 4, 5, 6, 7, 8. Whew, okay. So we've shown that AB is parallel to DC. That's good. Now here, you've got a rise over run of 1, 2, 3 over 2. So M equals 3/2 here. Then over here, you go up 1, 2, 3, right 1, 2. So M equals 3/2 here. All right, because you have 2 pairs of opposite sides, which are parallel, you have a parallelogram. That's number 7. So there's a lot to talk about in terms of maybe not a lot to talk about, but just on your end, what I want you to do is make sure you know the definitions for a trapezoid, a rectangle, parallelogram, just all the quadrilaterals that you guys have previously talked about. Usually a quick Google search will give you sort of the skinny on it. So that's number 7. We're going to jump around to number 17. Where is my eraser? Number 17 gives you 2 linear equations, and it asks you to basically give the They give you two lines, and they're asking you to give the linear equations of those two lines. So I didn't have this document prepared yet. That's my bad. I should have had this on the screen here. Bottom line is I'll just explain how you're thinking about this. You can write the equation of any line using the y equals mx plus b format. If we can determine what the slope of the line is, and then maybe find the b value, which is the y-intercept, then all we got to do is plug in for the m, plug in for the b, and we've got the equation of the line. So if you look at the rise over run of the blue line in your textbook on page 17, it appears to be up 5, right 4. So we're talking blue line here. Up 5, right 4. Okay, and it appears to cross the x or the y-axis at -5.5, but I'm not exactly sure. So here's what I'm going to do. I'm going to take the point they give us for sure. There's for sure the point 2, 3, to -3 on that line. So what I'm going to do is I'm going to plug in the 2 for the x, because in order to pair is an xy. When x equals 2, y must equal -3. Okay, so I can use an algebra method. This is the algebra method for solving that b value, even though I'm not exactly sure if it crosses the x-axis at -5.5. So if you took 2 times 5 halves, just put the 2 over 1. You can cross-cancel 2 divided by 4 is 1/2. So -3 equals 5 times 1 over 2 times 1, 5 halves, plus b. 5 halves is the same as 2.5. And then to get b by itself, you'd subtract 2.5 from both sides. All right, my suspicions are correct. It is indeed -5.5. So instead of the b value right here, I'm going to plug in -5.5. And that would be the equation for my blue line. For the red line, I'm basically going to do the same thing, except I'm going to have a different slope showing up. Oh, it's exactly the same thing, except it's just flipping around the rise. So I'm still working with y equals mx plus b. The rise over run, instead of plus 5 over 4, it's going to be -5 over 4. If you look, they're basically saying that the same point on the right-hand side is going to match with that point on the left-hand side. They're almost creating like a rectangle there. So down 5, right 4 is our slope, and then we've got the point 2, -3. So I've got sort of like my formula equation. I can plug in -3 for y, -5/4 for m, times my x plus b. All right, this was just 2.5, but now it's -2.5, which means I'm going to add 2.5 to both sides. Opposites subtract, so 3 minus 2.5 is 1/2. The bigger number is negative, so keep the negative. Okay. Y equals -5/4 x minus 1/2. So that's how you guys can think your way through something like number 17 or 18. Okay, turn your attention now to number 21. I don't think I need the graphing grid, but I'll just keep it handy just in case we need to reference it. So 21 asks to find a general form of the equation of the line through the point A that satisfies the given conditions. So they give us the point 3, -1, and they're saying give us the equation of a line that's parallel to the y-axis. And one that's perpendicular to the x-axis. So here's what I'm going to do to start this out. I'm actually going to use the graph, plot the point 3, -1, and then I ask myself, what kind of line would be parallel to the y-axis? Well, the y-axis is a vertical line, and we talked earlier about how vertical lines have a very special equation formula. It's not y = mx + b. The equation of this line basically needs to communicate that the x-coordinate is always 3. So it contains all the points 3, 1, 3, 2, 3, 7, 3, -5. The x value equals 3. And that's what the equation of the line that's parallel to the y-axis that must go through 3, -1 is. For the next part, I wrote that down wrong. This already is perpendicular to the x-axis. It said it's perpendicular to the y-axis. Sorry for the confusion. Perpendicular to the y-axis just means it's going to form a right angle with the y-axis. Okay, so here's our line that went through 3, -1. It forms a right angle right there. Horizontal lines basically mean all the y values are -1. All the y values are -1. So we communicate that by saying y equals -1. Okay, not much to 21. 27's a little more involved. They give us 2 points to plot, and you're asked to write the equation of that line. Now they keep using this term general form. I'm a big fan of just writing it in slope-intercept form. So, but I'll talk to you guys about the differences between the two. All right, so number 27 states point A is 4, -5, point B is -3, 6. So 4, -5, and 3, -6. No, -3, 6. Whew. All right, can you guys see that okay? Yeah, you can see it all right. So we're going to utilize this formula right here, which means it's kind of a 3-step process. Step 1, I need to find slope, which you were given a formula back in the day, y2 minus y1 over x2 minus x1, where the left are x's, the rights are y's, and you just have to subtract. So 6 minus -5 is our numerator, -3 minus 4 is our denominator. It comes out to be positive 11, because these two negatives become plus. Same sign, add, take the sign of the negative. -11/7 will be our m. Step 2. This is where we pick one of these two ordered pairs and plug in like we were on, I think, number 17, I believe? 17. Kind of. Like we're just saying, hey, let x equal either 4 or -3. So I'll pick, I don't know, I'll pick -3. Now if I pick x equals -3, I must pick y equals 6 now, and then use the fact that m is -11/7 and plug all three of those pieces of information into y equals mx plus b. That'll give us just b as the one variable, and then we can get it by itself. So 6 equals negative 3 times negative 11 sevenths plus b. So just make sure you know your basic algebra rules. I mean, it's great to have the calculator for convenience, but please be aware that to multiply a whole number times a fraction, you put it over 1, top times top, bottom times bottom. If you can't cross cancel, so it's 6 is equal to a negative times a negative, positive 33 over 7 plus b. Yeah, and I'm already predicting that we're going to be subtracting these two. So I think I'm going to make 6 into a fraction with a denominator of 7. So 6 over 1 is the same as 6 times 7 over 1 times 7, which is 42 over 7. So I got 42 over 7 on the left, 33 over 7 on the right, plus b. I subtract this from both sides to get b by itself. And you're given 9 over 7. That's my b value. So here's what slope-intercept form looks like. Slope-intercept form, which is sort of like step 3, you would actually write the equation y as my placeholder variable equals negative 11 sevenths x plus 9 sevenths, or 1 2 sevenths. Now, I'm okay with just accepting this, but know this. The general form is where they don't want any fractions in it. So they're basically saying, take y equals negative 17 over negative 11 over 7x plus 9 over 7. Take that equation. I'll just use this. Well, you know what? This video's almost done. I'll just turn that off. Take this equation. In order to get rid of this fraction 7 on the bottom both times, I can just multiply both sides by 7. So that creates 7 times y equals the 7 here cancels with the 7 there, negative 11x. The 7 here cancels with the 7 there, plus 9. And I believe what they do is they do ax plus by equals some constant value. So they would add 11 to both sides. So 11x plus 7y equals 9 is technically standard form or the general form. Yeah, but I think the more practical approach is making sure you're able to put it in slope-intercept form.